So my journey with rote math began with vertical subtraction. And it didn't begin as a child. I do distinctly remember not enjoying vertical subtracting as a child, but I did it because we all did it. We all learned the standard algorithm. And to this day, students all across the country are learned the same exact standard algorithm that I learned as a child. So at least it's familiar. Yeah, it's got that going for it. But it was when I was student teaching, when I was just starting to become a teacher, I had no idea that I was going to end up being a math teacher, mind you. I was just wanting to be an elementary school teacher at the time. And I was student teaching in a fourth grade classroom. And I was watching this fourth grade teacher teach vertical subtraction. And it brought back all the memories of why I hate the standard algorithm of vertical subtraction. And we all know how it goes. We all know the teacher stands up in the front of the class and she goes, well, we're going to try and subtract 3 minus 5, but we can't subtract 3 minus 5. And in my head, I'm thinking, well, I mean, yeah, you can, but we don't. You haven't told the kids that negative numbers exist yet. But we can't do that, so we're going to borrow a 10 from the next place value. You see, if you cross out the 2 and replace it with a 1, then that means you can take 1 from it and you can stick it next to the 3. You can just kind of wedge it in there. Then turn your 3 into a 13. And at the time, I'm thinking to myself, oh my God, this is it. This is where it begins. We teach these students that math makes sense and that there's order and reason to the way in which we should organize our math. And then vertical addition goes just fine. And then suddenly with vertical subtraction, oh, we're crossing numbers out. We're squeezing numbers into the place value. I thought place values were supposed to be sacred. I thought there was 1 digit per place value. No, apparently, if you're doing vertical subtraction, you can squeeze an extra 1 in there because why not? You know, why not? So at the time, I'm thinking, oh my God, I feel so bad for these kids. And, feel bad for my former self. There's got to be a better way. There must have been. And so, me knowing very little about math, I just thought, let me just start experimenting with this. So while the teacher is teaching, okay, so we turn this, we get 8. And then, of course, this 1 now, well, this is, we got to borrow again from the next one. And we're going to stick a 1 next to this one. Not next to the 2, mind you, because it's already been turned into a 1 from the borrowing from prior. So this is now an 11. So 11 minus 9, that gets us 2, and then 3 minus 1, that gets us another 2, and we get 228. And yeah, you do. You do. And if you're good at the standard algorithm and you like it and you're fine, then you probably shouldn't be watching this video. But if you're like me and you hate it, you hate the fact that it's a mess, and you want something neater, well, then you're in the position that I was in that day in the classroom. And that very day, I set my sights on there's got to be a neater way. There's got to be a way to do this that doesn't involve crossing out, that doesn't involve squeezing digits into place values where they don't belong. Come on, we can do this. Why can't vertical subtraction be more like vertical addition? And I know why not in general. It's, you can't just carry things over. It doesn't work like that. But, well, maybe we can do something with it. Maybe with my adult brain, knowing that negative numbers exist, maybe I can answer the question, well, what if I just don't borrow? What happens then? What does the answer look like then? And so I tried it. I just tried it. I wrote the number on a whiteboard, and I just tried it. And and tried to make sense of what I got. And what I got was something that looked ugly. It did look ugly. 3 minus 5 is negative 2. So, pot calling the kettle black. Here I am squeezing a negative sign into a place value. 2 minus 9, well, that's negative 7. And then 4 minus 1 is 3. Oh, that answer's pretty ugly. But I stuck with it. I was like, well, there's got to be some way that this equals this. And so I started working through it, place value by place value. I'm like, well, this is 300. Minus 7. Well, that's in the tens, so we could think of that as minus 70, right? So minus 70. Oh, wait, 300 minus 70 is 230. Wait, I'm almost there. Minus 2 more. There's my 228. I got it. And I thought to myself, that wasn't actually that hard. That wasn't that hard to do in my head. 300 minus 70 is 230. 230 minus 2 is 228. I don't even need to write out this expanded form. I could just, I could read that. And so, I tried it again. I was like, okay, I'm going to come up with another one. Well, 1 minus 6, that's negative 5. 2 minus 4, that's negative 2. 5 minus 3 is 2. Can I read this? You bet I can. 200 minus 20, that's 180. 180 minus 5 is 175. Oh, no mess. No crossing out. That went fast. Yeah, I think I'm onto something here. And so, when the pandemic started, I was tutoring a third grader in her home. And I thought, well, why don't let's experiment. Let's see if I can teach a kid this. And a third grader, no less. So just starting to learn the ideas of subtraction. I was like, all right. And I started by teaching her about single-digit negative numbers because that's a prerequisite, right? You got to learn that. But the key here was that I kept it simple. I'm not teaching her the entire unit on negative numbers. Instead, I'm just teaching her one single skill. What happens if I switch around the numbers? If I start with the smaller number and I subtract the larger number. So I started by doing what's 3 minus 5? And she, of course, answered 2. And I said, nope, not 2. 5 minus 3 is 2. And he's like, oh, yeah. And he's like, okay, 0. And I'm like, no, it's not 0 because we're subtracting more than we have, not the same amount. 3 minus 3 is 0. 3 minus 5 is lower than 0. And he's like, well, what is it? I was like, well, 3 minus 5 is negative 2. Negative 2? What's that? I'm like, well, it's, if you go further down than 0, it's like saying I subtracted everything I could subtract, and we still have to subtract 2 more. And she's like, oh, I get that. And so I then started presenting her with pairs of problems. I would start with, what is 7 minus 5? And she would write, that's 2. And I'd go, all right, what's 5 minus 7? And it didn't take long at all. She was like, oh, that's negative 2, because I switched the numbers around. And she picked up on the pattern pretty quickly. What's 8 minus 3? Oh, that's 5. What's 3 minus 8? Oh, that's negative 5. And eventually I was able to just present her with individual problems. Oh, what's 9 minus 2? Sorry, not what's 9 minus 2. What's 2 minus 9? Oh, that's negative 7. Didn't even need the positive version to prompt her. Understood the fact that it's the same as 9 minus 2, but in negative sign. This took 5-10 minutes max to teach this. And then from this launchpad, I taught her this. She picked it up real quick. I was proud of myself. I was enjoying myself. And then she shows her dad. And then her dad pulls me aside and says, what are you teaching my daughter? And, me being proud of my accomplishments, like, I came up with this new way to do vertical subtraction. And she picked it up real quick, and she's doing a great job. And he's like, you can't just teach her a different way of doing subtraction. You have to teach the standard algorithm, because the standard algorithm is what she's going to learn in school. You can't be teaching her a different thing. And I thought to myself, you're right. You're right. And so, it kind of made me a little sad that I was going to have to keep this to myself. But I kept to myself for a while, and I understood, well, this can only get you so far. Eventually, you're going to have to deal with bigger numbers. You're going to have to deal with numbers with decimals. Can you mental math your way to those numbers as easily as you can do with the 2-digit and 3-digit numbers? And I had to admit I couldn't. Even practicing by myself. No, not working for me. So I set back to the drawing board. And I was like, well, if I'm going to introduce this to students, it can't just be a gimmick for small numbers. It needs to be something that can be applied to all vertical subtraction. Because I had it in my mind that I was going to replace the standard algorithm, not just come up with a gimmick. And so I set to work coming up with a way to do it with larger numbers, ones that I couldn't mental math as easily. So I would come up with a large number problem, and I would do it out, and it would have lots of negative numbers like this one, and I would have to fix my way to victory without the aid of mental math, because it's too many digits, and there's decimals involved. It takes too much time. I want it to be quick. I want it to be faster than standard algorithm. I want it to be easier than standard algorithm. Is that possible? Well, in my opinion, yes, it is possible. And to show that I'm not such a maverick, the fact is that I did basically copy the borrowing process from the standard algorithm. But I wanted it to not be something that you do at the beginning that involves crossing out and replacing numbers and ending up with numbers in the teens, but rather something we can do at the end. Once we've gotten this set of digits, we're halfway there, and we just need to fix the negative ones and make them positive. And that's actually not that hard. By using the borrowing process, it's understood that you take one away from the next place value, and then you can basically add 10 to the place value that has the negative number. And it really is as simple as that. And the nice thing about this was it's always 10. It's never 11 or 13 or 15 or, God forbid, 18. It's always 10. And that made life easy. So I just thought to myself, 10 minus 7 is 3. Well, that was easy. Okay, so now this is a negative 1 because I subtracted 1 from it, so I'm going to have to subtract 1 from the next one and do the same here. And I stopped even writing the tens. I can just understand that it's 10. So 10 minus 1, well, that's 9. Well, this is negative 2, so subtract 1. Well, so this is 10 minus 9 minus 1, well, that's 10 minus 10. So that results in 0. And then keep going. Oh, minus 1 over here. 10 minus 1 minus 1, that's 10 minus 2. That results in 8. 10 minus 4 gets a 6. And 4 minus 1 gets me 3. And so I'd come up with a formulaic way of approaching this. And it was fun. I enjoyed myself. I enjoyed the fact that I had created this. And if you hate standard algorithm like I do, maybe you'll enjoy this as well. So with that being said, I've got a few practice problems. You're welcome to nosh on. I will deliver the answers shortly thereafter, and you can see if your skills are getting up to par with mine, if this is something that you want to learn. So go ahead and try them, and then I'll write down the answers. So these are the digits that I come out with for the first one. These are the digits that I come out with for the second one. For the first one, I'm thinking of this as 900 minus 20. That's 880. 880 minus 7. That's 873. Over here, even easier. 130 minus 2. That's 128. So that's the mental math ones. Now we'll try a couple harder ones. Give them a try. And let's see if you come up with what I came up with. So this comes out to be negative 2. This is negative 3. Negative 6. Positive 2, positive 1. Sorry, not positive 1. 0. And then over here, -6, 0, -2, and +1. All right, see if you can fix them so that they're all positive. So over here, -1 makes this 8, -1, this is 6, -1, this is 3, and 1. 1.368. Over here, on the other hand, -1 turns this into a 4, -1, this is a 9, -1, this is a 7, and then that's a 0 after the decimal point, or before the decimal point. So 0.794. I think by now you've received enough instruction from me. If you want to practice more, I suggest doing what I did. Just write a problem, a random problem, down on paper, solve it, and then check with the calculator. And repeat it 5 to 10 times. By the end of 5 to 10 times, you're probably doing this just as easily as I am.